A prehistoric shepherd needs to track a massive herd of goats across a dusty plain. Without spoken words for numbers, they require a reliable way to ensure every animal is accounted for. Humans have an innate ability called subitizing, the capacity to instantly recognize small quantities without counting. As these patterns show, we can identify 2 or 3 items at a glance, but our brain hits a wall once a group exceeds 4. Beyond that, the quantity simply registers as a cloud of many. To track a larger herd, early humans relied on one-to-one correspondence. They bypassed their mental limits by matching one physical mark directly to one real-world item. Artifacts like the Lubombo and Ishango bones provide physical evidence of this practice. These deliberate tally marks allowed humans to store and recall quantities over 20,000 years ago. This approach relies on a principle of cognitive economy. An individual doesn't need to invent a spoken name for the number 42 to track 42 antelopes. They only need to understand that each notch represents a specific animal. While bone carvings are permanent, tracking a fluctuating herd requires a flexible system. Eventually, people began using loose pebbles in a bag, adding or removing stones as the inventory changed. This required a significant leap in abstraction. A person had to accept that a small, smooth stone, which looks nothing like a sheep, could effectively represent one. This symbolic substitution uses the same cognitive skills required to develop art and complex language. One thing is allowed to stand for another. In ancient Sumer, around 3500 BCE, the first records of complex counting began to appear in modern-day Iraq. The city of Uruk operated a massive economic system, where the central temple served as a warehouse for taxes and rations. As trade volumes scaled to thousands of bushels of grain and jars of oil, the old pebble system became a logistical nightmare. Carrying a physical stone for every single item in the city was no longer practical. The birth of abstract numbers was a practical response to the heavy logistical demands of a growing city bureaucracy. Sumerians used specialized clay tokens to track these assets. In this system, a small cone represented a small measure of grain, while a larger sphere stood for a larger quantity. To prevent anyone from tampering with the count during transport, accountants sealed the tokens inside a hollow clay ball called a bulla. This acted as a secure envelope for the transaction. This specialized system introduced the concept of grouping. Instead of carrying 10 individual cones, a merchant could substitute them for one large sphere token. By tracking groups of objects rather than individuals, humans exponentially increased their counting range without needing to manage massive piles of clay. When early humans looked for a way to group these tokens, they often used their own bodies as a guide. We count in base 10 today, simply because we have 10 fingers. Some cultures used a base 12 system. By using the thumb as a pointer, a person can count the 12 bone segments, or phalanges, on the 4 fingers of a single hand. The Sumerians developed a system based on 60, a highly composite number. This means it can be divided perfectly by a wide range of integers, including 2, 3, 4, 5, and 6. This solved the ancient trade problem of fractions. 60 measures of grain can be split equally among a team of 3 or 4 workers without any messy remainders or the need to physically break tokens. Before humans wrote down equations, they performed concrete arithmetic. They simulated real-world events by moving physical objects across a surface. The merging piles method was the physical precursor to addition. To calculate a total tax collection, administrators simply swept separate piles of tokens together. Multiplication was performed using one-to-many substitution. To pay 5 workers 2 measures of barley each, a foreman lays out 5 worker tokens and systematically replaces them with 2 barley tokens to reach the final payout of 10. Division worked in reverse. A large supply of barley is sorted into small clusters of 2. Each cluster is then swapped for a single worker icon to show exactly how many people can be hired. These physical methods provided a way to organize complex resources and pay workers, finally allowing humans to bypass the biological limits of their own brains.